Honors Chemistry, and welcome to Chapter 5, Section 5.9, the last of our naming section. So, acids. Previously, we talked about naming ionic compounds, right? Where ionic compounds, as a refresher, ionic compounds where we have first a metal and a nonmetal, or a metal and a polyatomic ion, or a combination of polyatomic ions, right? It can be type 1 or type 2. And then from there, we would further differentiate into binary or polyatomic ion, right? Oh, do be mindful, I forgot to mention, there's that one special polyatomic cation, and there's only one of those, right? So you would only ever use that one. We'll do practice, don't worry. We could also have a molecular compound, which would be composed of 2 or more nonmetals, right? That's your cue, that's what you're looking for. And if a compound is made of 2 or more nonmetals, then you will follow the numerical prefix system, right? And still end it with "ide" because it is still binary, right? Then that brings us to our last type of compound, which is acids, right? Where acids, one of the giveaways are going to be that we're going to have an H out front, okay? For our purposes, right? Most of our acids behave like ionic compounds, right? They behave like ionic compounds, so we're going to kind of write them that way, right? Where our H's, if we think back to our periodic table, are in group 1. They are not metals, but they often form cations like metals, or we can treat them like cations like a metal, right? And they form an H+, so it sort of makes sense that this would be the element we would put first, right? And it will be attached to some type of anion, and that anion can be some other element, or it can be a polyatomic ion, right? And those are our options. So our acid can be binary, so only 2 elements, so it'll be H and an element, right? Or it can be an oxyacid, which means H and a polyatomic ion. Yes, those are your 2 options for acids, right? Now, an oxyacid can be further differentiated, where does that polyatomic ion end in "ite," or does that polyatomic ion end in "ate"? Because then that tells you how you're going to write your oxyacid's name, okay? So let's just look at some practice, some names as examples, and then we will fill in our table, and then we'll do a couple together. All right, so again, starts with an H. That's what tells you it's an acid, right? The fact that there's only one other element means binary. So we're going to see that this binary acid starts with a hydro, and then we have a root, just like we did before, and then it ends with ic and acid, yes? Hydro, brom, ic acid, right? So if we go look at our table, right, this is going to be hydro, and then we're going to use our root of the nonmetal, which are going to be those same roots that we talked about for ionic compounds, right? And it's going to end with ic and then acid, right? So hydro, root, ic, acid, yes? All right. Then let's look at some other types of acids, right? So here we have, more H's, but we have also oxygens and more than 2 elements, which means that that's your clue, right? That these are all going to be polys, right? Which means that what we're really looking for is what is the polyatomic ion, right? That's important, right? This polyatomic ion, ClO4, is perchlorate, right? Which means it ends with 8, right? And then we'll see that the perchlorate becomes perchloric acid, yes? So we no prefix, right? No prefix. And then we use the root ic acid. And by root, that just means everything that comes before the 8, yes? So we have no prefix. We're going to use the polyatomic ion's root, right? And then we're going to end with ic acid. Basically what we're saying here is we drop the 8. Okay? Now, here we have ClO2, and ClO2 is called chlorite, right? So chlorite, then we look over here, becomes us, yes? We take that root of chlor, and then we change the ending to us, and then acid, yes? So no prefix, polyatomic ion root, and here basically what we're saying is we'll drop the ite, right? and we'll replace it with us and end it with acid, yes? So if we take that down here, we have H. Now it says 2, but we'll talk about that later, but really the key part is it starts with an H. We need to figure out what CO3 is. CO3 is, right, carbonate, and we'll note here, oh, we dropped the 8 and it became carbonic, still no prefix because the only types of acids that get prefixes are binary, correct, right? So here, what happens when we write the formula for an acid, we write it just like we do for an ionic compound, where it's about balancing the magnitude of charge, right? Where if we take a look at a periodic table, right, so again, hydrogen has a charge of +1, and so layering in our charges here, right, if this is +1 and bromine is -1, right, we need one of each. This is +1, perchlorate is -1, right, +1, -1. This now we have +1 and 2-, right, which means we have 1 is equal to 2, which means we need 2 of those hydrogens, yes? Does that make sense? Right? All right, so let's do a few practice together. So here we have, oh, starts with an H, probably an acid. Oh, it's only got one other element, means it must be, ding ding, binary acid. So we will use the hydro prefix, because that goes with binary acids. Then we'll use the iode, which is the root for iodine, and end it with ic and then acid, hydroiodic acid. Here we have a hydrogen, which tells us acid, and we have that, so definitely it's going to be an oxyacid. Then we'll think to ourselves, well, what is PO4 called? And you would say, right, PO4 is called phosphate, right? Which means it's one of these. So we're going to, no prefix, root of the polyatomic ion. Here it gets a little funny because you might be like, ooh, phosphic acid, right? No, because for our phosphate and phosphite and for sulfate and sulfite, we add back in a syllable kind of back to what the nonmetal it's made of, right? So it's made of phosphorus, right? So we're going to go phosphoric acid, yes? So just, make a special note as you're memorizing these, right, that the phosphorus-based ones and the sulfur-based ones kind of go back to the element name as opposed to the root of the polyatomic ion's name, right? So if we look here, we have H3, oh, PO4, definitely an oxyacid. And what's PO3 called? Right, one less, right? So phosphite, which means that we would follow that model, which says phos for us acid, yes? Where the ite just got replaced with the us, right? And we added back that syllable for the phosphorus, yes? Okay, now sulfurous acid, right? So first we would note the ending, so it's got acid, which tells you it's H plus something, right? This us ending tells you that it's it's an oxyacid that came from a polyatomic ion that ended with ite. So it came from sulfite, right? So sulfite is SO3, 2-. I know it also has H plus, and so then it's about balancing the magnitude of charge, which means H2SO3, yes? All right, next up, acetic acid. So acid tells you, oh, it's an acid, starts with an H. Ic, in and of itself, doesn't tell you anything, but the absence of a prefix tells you, right, it must be one of these, right? So we would think to ourselves, that means acetic acid comes from acetate, right? Acetate is C2H3O2 and we know it has H plus, and that's our formula for acetic acid, right? Now, hydrofluoric acid. So acid tells you, oh, it's an acid, has an H in it. Ic, in and of itself, again, not indicative, but hydro, ding, 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 this is a binary acid, so it's simply H. And then this, which is fluorine, which has that, so that is my formula. Yes? All right. Practice, practice, practice. Again, right? We have to make sure that we know all the rules and we know all the pieces, right? Like our elements, what types of elements there are. We have to know our polyatomic ions, right? All of that, you have to study that well enough that it becomes second nature, And then you can layer on the rules, right? Okay, please make sure you practice and study, and don't worry, there's plenty of practice to follow. Thank you for listening. Be good, and I'll see you soon.